Thanks, Sam, for the introduction. And what I'm going to be talking about here is automated root cause analysis in wireless network. And as you can actually catch me on Twitter. That's Karan GHZ. And I'm a manager at Arista Networks, and I actively work on the cognitive Wi-Fi solution uh, at Arista. So let's define the problem statement first, right? So why do we need automated root cause analysis, right? So I think all of us know that when there is a Wi-Fi issue, right, we have all been doing root cause analysis, and some of that did show up in the previous two presentations. So there are essentially two aspects to it. One is connectivity issues, and the other category is the performance issues, right? So for connectivity issues, stage where almost every vendor is doing this, where they are able to monitor the AP state machine, and what that gives you is essentially what we call client journey, right? It tells you where exactly the client is failing. Is it failing in association, authentication, or DHCP, DNS, that kind of stuff, right? And finally, it tells you like how many clients are online, how many were not able to get online, right? So that's the connected part, and it's for the most part solved, right? Now, talking about performance issues, right? So it's not a state-based thing. You cannot define a state machine. It's very it's a very interdependent kind of a thing. So what do you do for performance issues? So that is where automated root cause analysis comes in, right? Now the idea is not to say that this an automated root cause analysis engine would solve all your problems. The idea is that it will reduce the time you have to spend uh, on solving that problem. That's the idea here. And I'm going to talk about that. So let's talk about what is an RCA engine, right? Like if you have to build one, like you have to first define what it is, right? So I'll talk about more specifically a Wi-Fi RCA engine. And so it has multiple components, and a lot of this information is coming from this paper which talks about surveys on models and techniques for root cause analysis. I would recommend that everyone check that out. Right. So it defines the space very well. So let's talk about a Wi-Fi RC engine, right? So the first thing is a symptom, right? So a symptom is essentially something that you see outside, like which is externally visible, like what's the issue, right? So for example, for a client, low data rate can be a symptom, right? And the other part, the other input to the engine will be observations. Like observations is the current data set, right? The current list of clients and the various properties that they have. What is the RSI they're getting? Are they experiencing high retry rate and things like that, right? So that constitutes your observation. Then domain knowledge, right? How are different Wi-Fi parameters relate to each other? So we'll talk about each of these in subsequent slides. The next one is system knowledge, right? So what is the configuration of your system? That's really important as well to understand like what are the different settings, SSID settings, right, in your network, right? So that's the other input to your root cause analysis engine. Now, once you give all this input, right, what do you get? So you get the root cause analysis. Essentially, it tells you what are the root causes of the symptoms. Like if a bunch of clients are facing low data rate in your network, right? What are the root causes? It can be interference, it can be coverage issues, and so on, right? Not only that, it can also provide you with recommendations, right? Like if it knows that this is the root cause, what are the things that you can do to fix it? Like for example, it can just tell you that if it's a coverage issue, turning on auto transmit power may help, right? And the evidence, right? So just saying that these are the root causes and these are the recommendations is not enough. We know that we want to see the evidence of such statements, so you can also present the evidences along with such root cause and recommendation. And evidence can include graphs and charts which validate the analysis that the engine has done, right? So let's talk about each of these in detail. So let's talk about observations first. And so what are your observations? As I said, right? So if you are doing a network level root cause analysis, your observations will include all clients along with their respective Wi-Fi parameters, right? So I'll explain in a later slide why I'm talking about all clients and not only about affected clients. We'll look into that. And the other observation data set will be if you're doing a single client RCA, like you know that this client is facing an issue and you want to debug that, then you essentially gather all the parameters of that client, maybe some historical data and so on, right? So this table here sort of just gives you a sample of the type of parameters. So for example, so client MAC is just a meta parameter, but like high retry rate, low RSI, capability issue, poor coverage, right? So these are some of the things that you would like to capture about the client, and each row corresponds to one client. And then these are all your parameters. These are potential root causes. And low data rate is your symptom. So this is what the clients are facing. A few of the clients are facing, right? So the yes indicates the client is facing that issue or not. So these are the observations that you gather from the system. Next, let's talk a bit more about the observations. So for simplicity of this discussion and for implementation, uh, let's assume that you sort of reduce each of the performance parameter to a Boolean flag, right? So you say whether the client is facing low data rate or not. Now that the system can decide, and each system can decide on its own, and or you can ask the user to configure a threshold and so on, or you can decide it based on relative to other clients and other things, right? So you can say whether there is high contention, whether there is Wi-Fi interference, and so on, right? So you convert this into Boolean flags. Now there can be other parameters as well, like where the client is, what is the vendor of the client, what is the operating system it is running, in case you know these things, and then what AP it is connected to, what SSID it is connected to. Now these parameters are not exactly root causes, but you can actually get some valuable insight in the sense that are most of the clients connected to this AP facing an issue, right? Things like that uh, can come out of the root cause analysis engine. And or maybe are most of these vendors, most of the devices from this vendor are facing issue in your network, right? So that's the idea. So next, let's talk about domain knowledge. And it essentially means that how different Wi-Fi parameters relate to each other. Again, this is not an exhaustive graph, but you can relate to it, right? So let's say poor app experience, which is what we care about finally, is the master symptom, and low data rate is sort of a sub symptom, if you want to call that. And this is roughly the relationship, right? And there might be other things here, right? Between the different parameters that the client has, right? And this is the domain knowledge, the Wi-Fi domain knowledge that also has to be part of your RCA engine. This is what the engine should know about, so that it can know how to relate them and how to look at different parameters. Now let's talk about system knowledge, right? So these are like configuration settings of your system. Things like what is on, like is DCS on, is there a captive portal, is 5 gigahertz being used, or auto transmit power is on, and so on, right? There are like multitude of these config parameters. Now there can be other parameters like list of APs, then how you structure the APs in logical or groups. So in our case, we have a location tree to group the access points. So that can also be important, like that's part of the state of your system, right? So this is what your system knowledge is. So we have covered these three things here on the side. Now let's go into a bit more detail about what a symptom is, right? So a symptom is something like, let's say you have a fever, right? So your temperature is above the regular body temperature. So that is a symptom, right? So how do you define a symptom? Uh, so a symptom is an external manifestation of failure. So this quote is coming from that paper that I mentioned earlier. So it's sort of an academic definition. So it's an external manifestation of the failure, and this includes direct observation of failures themselves and externally visible indicators that a failure happened that are not failures themselves, like alarms raised by anomaly detectors, right? So in other words, it is essentially an externally observable parameter that indicates that something is wrong with the system, right? So for example, the body temperature. So it's an external parameter that you can detect and measure, right? So in case of Wi-Fi, you can define essentially two high-level symptoms. One is that uh, the client is facing poor app experience. Now, getting to that is not exactly easy, but I mean, that's the idea. Other can be low data rate, which is more easily measured, right? You can do it through threshold, right? Configurable threshold. And so these are the symptoms that you can define for a Wi-Fi network for a client. And the job of a RCA engine is to look at these observations, all the observation data that we talked about earlier, and infer which of the many root causes are responsible for one or more of the above symptoms, right? So, so we'll talk about this, like when we say, like, what do we mean by one of the many root causes, right? So let's go to root causes now. Root cause, in case of root cause, right? Like, so for example, you have a fever. Now the root cause can be that you actually have a viral infection, right? So that is the actual root cause, but the body temperature can be for various reasons, right? So you need to get down to so there are many possibilities, and you need to get to the maybe subset of those possibilities. You need to drill down to a subset so that it's easy for you to understand what's going on. So so in this case, so we come back to this diagram, you'll see that we have these low data rate and poor app experience, which we call as symptoms. And the root causes are at the periphery, right? And as this definition goes, right, root causes are events that can cause other events, but are not themselves caused by other events, right? So these are like right at the low level thing, right, which is causing that thing to happen, right? For example, it can be poor coverage that is causing low data rate, or it can be non-Wi-Fi interference which is causing low data rate, and so on, right? So that is what we define as root cause. And the idea is that can the system help you narrow down to a few of them, or maybe a couple of them, or one of them, right? Which will really reduce the time you have to spend on debugging that issue. Right? That's the idea here. And there can be some additional root causes which are not root causes in the strict sense of the term, but these can be like which location, which vendor, which OS, which access point, right? So we talked about this earlier. So you can also make these as part of your analysis, right? Now let's talk about recommendations quickly. So recommendations are actions suggested by the system that can help the user mitigate the root cause. So you have identified the root cause, maybe a couple of them. Now, what can the user do to fix those issues or mitigate those issues, right? Again, not all root causes may be actionable. So depends on what root cause the system has come up with. And in this case, like in this diagram, for example, if poor coverage is the root cause, you can say increase transmit power. Now, these are suggestions, okay? So these are not like, you're just telling the engineer that this is what is supposed to be done. These are suggestions that can, the actions that the engineer can take. And there can be multiple suggestions for each root cause. For sticky client, you can say enable client steering. For Wi-Fi interference, you can just say that, check if there are other RF devices nearby. For too many clients, for high contention due to too many clients, you can say that there are probably too many clients on the channel. Maybe you want to turn on auto channel selection. And similarly, for band issues, you can say enable 5 gigahertz band. If it's not enabled, upgrade your client cards or enable band steering, right? Many of these are applicable. For client capability issues, you cannot do much more than saying you can just upgrade the client cards. So these are the recommendations that the system can make. One thing to note here is that you don't want to blindly make this suggestions, recommendations. The system can intelligently check that, if it's saying enable band steering, whether it's enabled or not, right? So if it's already enabled, there is no point in making that recommendation, right? So it can not include it in its set of recommendations. So that kind of filtering can also be done. Now, next, let's talk about the types of RCA engines. We briefly touched upon it. So there are two types, roughly. One is the single client RCA engine and the multi-client RCA engine. Now, the single client engine essentially runs on runs on the data for a single client. It essentially analyzes issues with a single client. Because you are analyzing a single client, you can actually analyze many more features of that client, and you can look into historical data, right? And for the multi-client, you essentially look at the entire network. You look at all the clients in the network, or all the clients at a location in the network. And the number of features are limited in this case. And location, where the client is an important feature here. And this is usually useful when you're debugging a network-wide issue. If you are seeing many clients facing issues, right, then this is useful for that. So we'll look into the multi-client engine first. So what is the process, right? So if you trigger the root cause analysis engine, right, what does it do, right? So essentially, it collects the observations, the data, the table that we saw, the list of clients with their parameters, and for each location. So each location means each physical sort of environment, Wi-Fi environment, because you don't want to mix uh, maybe a warehouse with an office, right? These are two different environments. Running a engine across them may not give you very good results, right? So you do it for different locations. So you get observations only for that location. The RCA engine looks at all the inputs that we talked about earlier, and it generates the root cause analysis statements, which includes what are the root causes, what are the recommendations, and what is the evidence, right? Then you have this multiple of these statements coming from each location, and then you rank and display the RCA statements, right? So ranking is important because if you are more confident about one statement than the other, then you want to keep it on the top, right? And you can look at multiple ways of ranking them. One is that you can just look at how many affected clients are involved in that statement, right? Or you can look at how many total clients are involved in the statement. So there can be multiple strategies of ranking the statements. Again, what we have not looked at is how do you do the root cause analysis, right? So there are like many ways in which you can do root cause analysis, but here in this case, in this presentation, we'll look at one way of doing it. So which is using machine learning and using one of the most understood and or rather easy to understand algorithm, which is the decision tree algorithm, right, in machine learning. So the idea is simple, but it's sort of not how you would typically use a decision tree, right, or any machine learning model. So you have this data that we talked about earlier, a list of all the clients, and you train a decision tree model. Okay, so you essentially train a model where you have the target and the features, right? And you say that, okay, if these are the features and this is the target, then build me a model which predicts, given this feature, what will the client be affected or not, right? So that is what you would typically use a model for. You will build a model, then you will predict whether this client will be facing an issue or not, right? But what we are doing is that instead of asking the model to predict, we are reading the model to see what it has learned, right, from the data. So let's say you have 1,000 clients along with all their parameters, and also which one of those are facing low data rate or not. you train the tree and you read the tree to understand what's going on, right? What has it learned? Which parameters are most likely to indicate that this the client is affected, right? So we don't use the model to predict anything. We just read the model to generate the statement. So we'll look at it in more detail later. So let me first justify the data that we are using and why we need to use all the clients. So you may think that why not just let's summarize, let's just find how many clients are facing high retry rate or how many have capability issues. Let us just list them out, right? That's good enough. Why do we need sort of a learning algorithm to understand what's going on? So this is just a small attempt to justify why we need a learning algorithm in this case, or a slightly more involved algorithm than just summarizing the data that you have. So let's look at this example, right? So here we have a feature called, or a parameter called high retry rate, and the corresponding symptom, which is the low data rate, right? So so what I've done is, we have 4 clients which are facing low data rate and 4 clients which are not facing low data rate, and you sort of get this kind of a Boolean flag for high retry rate parameter. So yes, no, yes, no, yes, no, right? So you can see that if you look at this, the first 4 clients here, right, there is no correlation at all. It doesn't matter, right? So you have equal number of clients facing high retry rate in the yes category and equal number facing high retry rate in the no category. So there is no correlation. So this parameter is not useful. Just summing it up is not going to help, right? Now let's look at another example, which is the capability issue. Now let's say all your clients are sort of old, right? They are all old. But again, we see that, everyone has yes, but again, low data, 4 clients have low data rate and 4 clients don't have low data rate. So this is useless. Again, this parameter, talking about this parameter is useless, as you can see, because everything is yes. So there is no point in looking at it, right? Now let's look at poor coverage, which will demonstrate why this becomes important. So in case of poor coverage, we see that 3 out of 4 clients have a yes in this category, right? Versus 3 out of 4 clients have a no in the no category. So we can see a high level of correlation between poor coverage and low data rate, right? So you are able to establish that correlation, which we were not able to establish with capability or high retry rate, right? So this is why you need a learning algorithm. So learning algorithms are really good at actually deriving such relationships from the data, right? So it will actually derive this correlation and it will learn accordingly. And it will essentially ignore capability and high retry rate because they don't provide any valuable information, right? So that's why you need a list of all the clients. If you look at just the list of clients that are affected, you are actually looking at incomplete information in your network, right? So you need the happy clients as well as the unhappy clients to determine what is making the unhappy clients unhappy, right? So this is about the data. Now let's say you have this data, right? Like let's look at a sample decision tree that will be generated. So this is just a sample. So what this tree, so we can just assume that the algorithm generates such a tree from the data. So what this tree is telling you is that if there is high retry rate and if the client is operating in 2.4 gigahertz, then the client is likely to be affected, right? This tree is telling you that. And if you use it for prediction, that's what this tree is going to say if this and this is true for the client, right? So instead of asking it to predict, we just read it. We have this tree structure and we just read it. Okay, you start from the client is affected and you go back to the root. What we get is a statement which says that if the client operating in 2.4 gigahertz and that have high retry rate uh, is the reason why they're facing low data rate, right? So in other words, the clients are facing low data rate because they're facing high retry rate and are operating in 2.4 gigahertz. Okay. So it's simple, right? So the tree actually looks like this when you train a model on the data. So moving on, so this is a very high level overview of how you would create an RCA engine. Now let's look at the engine in action. So what we do is that, once you run the engine on low data rate, we give you the top affected locations. We also give you the top root cause analysis. So this screenshot is actually from a real customer, and it's actually as fresh as this morning. So you'll see that we talk about the top locations that are affected and how many clients in that location, right? And what are the top issues across the network. Then if you drill down, then for a given location, we tell you that, these are the clients. So I was talking about evidence, right? So this is the evidence. Okay, so I'm making a statement, or this engine is making a statement that 32 clients at this location face this issue. So which is that 2.4 gigahertz only networks, uh, which is interesting. So it's saying that clients have 5 gigahertz capability, but the Wi-Fi network is available only in 2.4 gigahertz, right? This is interesting, right? So this is something that is easily fixed and can improve the overall experience. So this is one statement that the engine has made. Now, if we go to the second statement, it's saying that there is high contention due to too many BSS IDs, right? And it also shows you like which clients are affected by this. It actually is giving you the contending access points, and if you click on that number, it will also give you the list of access points that are contending right on that channel. So in this case, this is the channel number 1. So these are the two statements. Now this is about a single location, but you can also look at statements across locations. So we have multiple statements being generated for this network, right? For different locations, different type of statements are being generated. So we have a high Wi-Fi interference statement as well here, and so on. So let's look at the recommendation, a sample recommendation from this same set of root cause statements. So if you click on that icon there, so what are the recommendations for high contentions, right? So it's actually recommending exactly what you can do, right? It's saying that you can set transmit power selection to auto and enable dynamic channel selection at that location, right? And related stuff. So so which can be valid, right? So it's a recommendation. It's also telling you which location you need to make that change to fix this issue. So uh, this is the recommendation part for multi-client RCA engine, right? So now let's quickly move to the single client RCA engine. Here the process is simpler. You collect the observations for a given client. You have a RCA engine which will work differently from a multi-client RCA engine, and then the final output is similar. You have root cause analysis statements which contain root causes, recommendation, and evidence, right? Now, in case of single client, there can be performance issues. So what we have found is that in a lot of cases, just a simple rule-based approach will work. So in this case, like for example, you have this data for a client, you can just check what all issues the client is facing and point them out, right? You don't have to do any learning or thing like that, right? You can also do some additional analysis for connectivity issues. So we said that connectivity issue stuff is mostly solved, but there are aspects which still you can work on. For example, the client is roaming aggressively, or the client is trying to connect to too many SSIDs. Let's say it is a managed client, enterprise client, it shouldn't be connecting to too many SSIDs, or there are frequent fast roaming failures, or there is high DHCP, AAA DNS latency that this particular client is facing. So and so on, right? So you can look at connectivity, uh, do some of this root cause analysis, right? But this can be rule based for the most part. What will a typical RCA statement look like for a single client, right? So if you debugging a single client, let's say a performance issue, so you can say that the client is facing low data rate and high retry rate because of the following reasons: high channel utilization and high Wi-Fi interference. And you can also add context to this. So you don't have to leave it there. You can show that, where does your client fit? So this line shows where this client fits in the network, right? When we say it's low data rate, right? And if we are saying high retry rate, then where is your client retry rate as compared to the rest of the network, right? So you can add context, you can add graphs and charts as we talked about. And let's look at this RCA single client RCA engine in action, right? So this is for a client in the network that we saw previously. And the RCA is saying that this is a slow BG only client and it can adversely impact 2.4 gigahertz Wi-Fi network connectivity, which is a useful RCA to have. And I think the only option really is to replace that client, right? So just one last bit on this whole thing, right? So talking about network assurance, right? There are many ways of doing this, but this is one of those ways. Is that you want to make sure your network is working fine, and you have this root cause analysis engine with you, which can give you detailed, in-depth analysis of what's happening in your network. So you can run it on demand, or what you can do is you can actually automatically trigger this on anomaly detection, right? So you have a baseline of your network, and if there is an anomaly, you automatically trigger it, you create a report and send it to the administrator. Or what you can do is you can uh, run it on a predefined schedule, maybe in the morning, evening, and get the reports accordingly, right? So it's up to the user how they want to schedule this or how they want to get this to trigger, right? So yeah, that's ends my presentation. Thanks a lot for listening. Anyone has any questions? Can take them now or maybe later.